And joining me now is Prineha Narang. She is the winner of the 2022 Outstanding Early Career Investigator Award. Congratulations.
Thank you. It's a real pleasure and honor to have received this award. I know some of the previous awardees and what they've gone on to do, so I feel a little bit of pressure.
First of all, you are doing a talk about illuminating quantum matter. Tell us about it.
Absolutely. So my group works on how we can, think about interactions in quantum matter, especially when you shine light on it. And to us, that means, either a laser interacting with a particular quantum material or putting some of these materials in a cavity. And you can use that to actually completely change the behavior of some of these materials. You can use that to actually, create new energy technologies, new quantum technologies. So it's very exciting. And I'm going to talk about some of that later today. So when we think about these problems, we think about them from a theory perspective. How can we actually model such interactions in a way that it's predictive? So whatever we ideally predict is then measured. I like that order of things. And hopefully the measurement somehow looks very similar to what we actually predicted. So, when you think about some of the current theory methods, and when I started my group, that was in 2017, well before COVID, we start to think about how can you model such interactions in a way that is computationally tractable while still being representative of what is physically happening. So, some of the interactions, you could previously write down an equation and say, well, this is what it should do, but we can't exactly model it. Now we've gotten to a point where, we have computers that are large enough, and we also have the methods that I've developed with my group that allow you to actually model such interactions. So these are non-equilibrium in many ways, which means that our material is not in a happy spot. It likes to be pushed away from its equilibrium spot. And out of equilibrium, it can do things that are fundamentally different, in some cases much better than in equilibrium. So I'm going to talk about all of that later today.
So how did you end up studying in this field?
So that's an interesting question. It's a little bit nonlinear, winding path. I started to think about, how we can build devices that are smaller, devices that could be, better than what we have today. And that's when I realized theory could have an impact. So when I was a graduate student, I originally thought I'd be an experimentalist. And this is actually for graduate students out there still trying to figure out, should I do this or that? Totally okay. I was that way. Realized very quickly that, theory can have a role in paving the way for the experiments that come in future. And some of the devices, some of these interactions we're predicting can then allow us to now, design new devices, completely new computing paradigms, for example. And that realization was a multi-year process for me to think that, I'm going to do this very fundamental theory stuff, computational stuff. I like tinkering with stuff, so I also wanted to do some experiment. Eventually got to a point where I said, I think this theory thing is going to work out for me.
And in 2021, you actually received an award named after Mildred Dresselhaus. Did you actually get a chance to meet her? She's a pioneer.
Getting the Millie Dresselhaus Prize was, another one of those moments where I thought, wow, this is crazy and awesome. I did get a chance to interact with Millie before she passed away. She was at MIT while I was there briefly as a postdoc. And I got a chance to, actually also be at a meeting where I presented and she was the meeting chair. It was a small workshop, not one of the MRS meetings. But she had a lot of feedback, and she said, hey, you're interested in this electron phonon problem. Of course, she worked in carbon nanomaterials for decades and said, this same thing shows up. Have you thought about this? And actually that led us to write a few papers, or some that were written after she passed, but yeah.
Well, thank you, Prineha. It was nice to meet you. Enjoy the rest of your week.
Thank you.